Hello friends, welcome to my YouTube channel of Debneel's Mathematics Desk. So before starting my video, as you can see, it's a new chapter for class 9. Okay, distance formula. And I know some of you might be wondering, you wrote part 1, part 2, part 3 in each of the chapters for all the classes. Why not today? The reason is this chapter has only one part. Okay, we can't take it to 2 to 3 parts. It will be boring, horrifying for you also. I don't want to do that. So it's a one video chapter, but it has a very important concept that you need to learn now, because this formula, the distance formula, comes in frequent uses in the higher class sums. Okay, so we will see what that formula is. So before starting my video, a huge thanks to all of you for showing your wonderful support to my channel. Keep supporting my channel if you found the content of my videos very informative and helpful and attractive as well. Leave a like and share and subscribe my channel. It motivates me to make better videos for my little friends on these interesting topics. And with that, I begin the new chapter for class 9. This one video chapter, distance formula, as the name suggests, has one formula. Okay, so many of you are accustomed with coordinate geometry, where you can suppose the point is there a, suppose it is 3 comma minus 2. This 3, this first part of a, it's called the abscissa. Okay, and the abscissa is always on the x-axis, remember this. And minus 2, or the second part of a, it is called the ordinate. And ordinate is always on the y-axis. Then suppose someone tells to you that the point A is on the y-axis, then that means what? The point A is only on y-axis, so it only has the ordinate. There will be no abscissa for that point. Suppose I tell point is on y-axis. Okay, then its coordinates will be what you know. The abscissa will be 0, because with x-axis nothing is there. It is lying on the y-axis. Okay, suppose like this. This is the axis is like this, right? X dash y, something like this. Yeah. So the point is lying on this x. Suppose here it is lying. So it has no connection with the y-axis, right? Sorry, here it is lying on y-axis. Okay, let's take the other example. So it is lying on y-axis. Suppose here it is lying. Then it has no connection with the x-axis, right? So there can be any coordinate for the x-axis. That is abscissa. Abscissa is for x-axis, so no abscissa can be there. But for as the point lies on y-axis, on some length from this center it must be lying. So we will write it as 0 comma y. So when you are told that a point lies on any of the axis, then for x-axis the abscissa will be there, ordinate will not be there. For y-axis, ordinate will be there, abscissa will not be there. Remember these small things. So why I told you, because now you will learn distance formula, which involves calculating the distance between 2 points. I am explaining how it is done. Suppose, so what do you do? Suppose you have been given 2 points on a page. Suppose here and here. And you will tell, sir, I am bringing out my scale, I am calculating the distance. Why are you teaching us this formula? Is that easy? Now what if I tell you the point A is 2 comma 3? That means from the center it is at a distance of 2 units from the x-axis, and from the center it is at a distance of 3 units from the y-axis. Okay, then suppose another point is there, B 4 comma 7. That is this point B, it is at a distance of 4 units from the x-axis. See, 4, this is the abscissa and it lies on the x-axis. Where does it lie? This 4 means it is 4 units away from the center on the x-axis, and 7 means it is the ordinate. It means that from the center B lies 7 units above on the y-axis. vertical, the y-axis is vertical and the x-axis is horizontal, right? Now bring out the scale and try to do this. You will fail miserably. So here comes the use of the distance formula. So forget about this two dots. Now consider these type of points. This means now we will be considering points on the Cartesian plane, that you know, the xy plane, it is called the Cartesian plane. So that is what we will be considering for the measure means distance calculation of points. Points on the Cartesian plane will only be considered. Don't just put a point on the road and another one in school and then use a means whatever type of machine to calculate the distance. That's not the distance formula. This distance formula is applicable for points on the Cartesian system only. So we will now see. So suppose this is 2 points A and B. A is 2 comma 3, B is 4 comma 7. Then the distance formula says then these 2 points A and B can be like this: x1 comma y1 and B is suppose x2 comma y2. That AB, the distance of AB is equal to root of y2 minus y1 whole square plus x2 minus x1 whole square. Okay. So then here's the, if you just compare, here x1 is 2, y1 is 3, x2 is 4, y2 is 7. Therefore here AB will be equal to root of y2 is 7 minus y1 is 3 square plus x2 is your 4 minus y2, sorry, x1 is your 2. See, 7 minus 3, 4 minus 2. Yes. Just compare x1, y1, 2, 3. x2, y2, 4, 7. Then just put in the equation. You get equal to root of 4 square 16 plus 2 square 4 root 20. Can write it as 2 root 5 units. Okay. That will be your answer. That's how you calculate the distance between points on the Cartesian plane. So this is a simple formula distance. So let me just write it aside for all of you to see properly. For 2 points, A x1 y1 comma B x2 comma y2, AB distance or the distance between the points equal to root of x2, it can be any way actually, x2 minus x1 whole square plus y2 minus y1 whole square. That is the formula. You can also do x1 minus x2 whole square, because we learned that any number, whether it is positive or negative, its square will be positive, so it will remain same. Okay, you can do x1 minus x2 whole square plus y1 minus y2 whole square anyhow, but don't do x2 minus y1 whole square, x1 minus y2 whole square. 2x will be in one side, 2y's will be in one side. That's the rule. And that's your distance formula between 2 points. I've considered them A and B, and these are the coordinates x1 y1 abscissa ordinate, again x2 y2 abscissa ordinate. And this is the distance between these 2 points. Okay, so remember this easy formula, it's a quite easy thing. Now we will be learning the various uses of this formula. So let's begin. So first of all, we have a easy heading. Find the distance between points. What are they? Okay, minus a comma minus b and a comma b. So we have been told to find the distance between minus a comma minus b and a comma b. So see, this minus a is x1, minus b is y1, a is x2, b is y2. Okay, then now put the values for distance equal to what? Root of x2 minus x1. x2 is a minus x1 is minus a minus minus a square plus y2 minus y1. y2 is b minus y1 is minus b square, and do equal to root of a plus a. This will be a plus a, so 2a square plus, so this is what, b plus b, 2b square, root of 4a square plus 4b square equal to root of 4 multiplied by a square plus b square. Now see, 4's root is 2, so we can write 2 into root of a square plus b square. That will be your answer. Quite easy. Here you have been directly given the 2 points. Just comparing x1, y1, x2, y2, put the values in the required formula. Okay. And then you get this a minus minus a plus a 2a, b minus minus b plus b 2b. Then do the squares. Here I take 4 common, 4 into a square plus b square. 4's root is 2, take 2 outside, multiplied by root of a square plus b square. So see, this chapter is not about that much learning many formulas. Okay, it's only one formula, but this formula has means various type of uses. You will learn. This is just the basics. This heading means what? I am giving a heading because few sums are there under this heading. It's the warm up. One video for one chapter. So obviously it should have something. Otherwise, why would the boards specify this syllabus for your exams? No need. Another one. Complex things. Anyhow, anything they give you. This root 3 plus 1 x1, 1 is y1, 0 is x2, root 3 is y2. Put the values of a distance. So it is what? x2 minus x1 whole square. x2 is 0 minus x1 is root 3 plus 1. Always be aware with the uses of brackets. Okay, x2 minus x1 whole square plus y2 minus y1 whole square. y2 is root 3, y1 is 1 whole square. Then do equal to 0 minus root 3 minus 1 whole square plus root 3 minus 1 whole square equal to minus root 3 minus 1 whole square plus root 3 minus 1 whole square equal to, now minus root 3 square plus 3 minus 1 square plus 1 plus 2 into a into b. Minus root 3 into minus 1 is plus root 3. Right. So this is the formula then. Plus 2 into root 3 plus, this is now what? Root 3 square 3 minus 1 square plus 1. So a minus b whole square. So minus 2 into a into b means minus 2 root 3. Then this is easy now. 4 plus 2 root 3 plus 4 minus 2 root 3. Crazy roots get out of the way, equal to root 8 equal to, you can write as 2 root 2 units. Always are units unless the units are specified like centimeter, millimeter, anything. So again, easy. Just see, comparing with x1, y1, x2, y2, x1, y1, x2, y2. Put the values in the equation or formula. Then be careful. x2 minus x1, so root 3 plus 1 is a compound term, so put it in within brackets. Then see, when you open up the brackets, the sign changes. Be careful with that. And then here also, then do the square. 0 minus 1 is minus 1, and root 3 minus 1 whole square. And do you can do a plus b whole square in any way. Okay, the squaring is game of joke for you also. I'm not worried about that. But what I'm worried about is this crazy 2 root 3 gets removed by plus 2 root 3 and minus 2 root 3. Good for our mathematical health. 4 plus 4, 8. Root 8 is 2 root 2, all of you know, units, and that's the distance between the points. So we are just simply putting the values in the distance formula and getting our answers. We are doing sums. Every sum has some value, otherwise it shouldn't be given in the exercises. Now this is something interesting. Origin and minus 5 comma minus 12. So wait. I will be telling what is this origin, where is x1, where is y1, who stole them? No one stole them, my dear. Origin in the Cartesian system, origin is 0 comma 0. Okay, means everything that's happening is happening from this point. This is the origin of everything. Okay, like where you are born, that's your origin. So this is the origin of Cartesian system. Cartesian plane is born from 0 comma 0, right? From 0 it increases in both the cases, in abscissa and ordinate. So this is the origin. This origin is 0 comma 0. Remember that this is equal to or 0 comma 0 and minus 5 comma minus 12. Now the game is yours. Now you have x1 y1 x2 y2. Let's solve. For distance equal to, so root of x2 minus x1 whole square, x2 is minus 5 minus x1 is 0 whole square, plus y2 minus y1 also, y2 is minus 12, again y1 is 0 whole square, equal to minus 5 square plus minus 12 square, equal to 5 square is 25 minus 12 square is 144, root 169, equal to 13 units. Gone, finished, goodbye, see you. So what was the difficulty? You just had to know one thing, origin is 0 comma 0, then you have the 2 points 0 comma 0 and minus 5 comma minus 12, x1 y1 x2 y2. Okay, now don't tell me that you means are confused with that. Abscissa and ordinate of this one is same. Yes, it can be. A point can be like this 2 comma 2. It means from x-axis and y-axis the point is 2 units away respectively from the center, right? On x-axis from center 2 units away, from on y-axis from center 2 units away. It can be like that, so don't get confused with that. So this is x1 y1 x2 y2, then put it in the formula, x2 minus x1 y2 minus y1. Finish the job quite easily, not a big deal. Now let's see what we have actually. What is the big deal then? Everything is a small deal actually till now. Okay, finally this stupid heading is out of the way. Warm up is done. Now time to get into the middle overs, you can say, in mathematics. So distance between now we are about to do typical algebra. 3 comma 1 and 0 comma x equal to is 5 units. Find x. Easy stuff, you already have x1 y1 x2 y2. So what will be the distance of these two points first of all? Or root of x2 minus x1 or 0 minus 3 whole square plus y2 minus y1 x minus 1 whole square. This distance between these 2 points is given as 5 units. So we can write that. Now let's solve. Or minus 3 square plus x square minus 2x plus 1 equal to 5 units. Or root of x square minus 2x minus 3 square is 9, 9 plus 1 equal to 10, equal to 5 units. I'm not writing units, okay, it's complicated for doing the calculation. Then if you square both sides, this root will get out of the way, so squaring. So here I am writing squaring on both sides. Then do this one square will be just remove the root and write the expression, and 5 square you know 25. Or x square minus 2x plus 10 minus 25 means minus 15 equal to 0. then a quadratic equation is here for us. So solving this equation is easy for you all, so let me just solve it directly here. This is easy. Equal to 0. That means what? X plus 3 equal to 0, x minus 5 equal to 0, or x equal to minus 3 comma x minus 5 equal to 0 means what? X equal to 5. Yeah, those are the values possible for x. Okay, so again, what was there any difficulty in this? Nothing. Just like the previous sums, you tell what will be the distance formula for these 2 points, x1 y1 x2 y2. It can be x the ordinate, but just consider it. Then x2 minus x1 whole square plus y2 minus y1 whole square, done, equal to the distance is given to us 5 units. Then just calculate this and get this one, this expression. Now if you square on both sides, this root gets removed and here 5 square 25. Alright, not a big deal, not a big issue. Then you shift this 25 to this side, minus 25 minus 15. Then do the quadratic equation, breaking up of the middle term. Minus 5 3s are minus 15, minus 5 plus 3 minus 2. Already done. Then take x common and do it. X plus 3 into x minus 5 equal to 0. That means x plus 3 equal to 0 and x minus 5 equal to 0. Okay. Then x plus 3 equal to 0, then x equal to minus 3, and x minus 5 equal to 0, then x equal to 5. Those are the two possible values for x. So that's easy. Just directly use the distance formula. Distance is given. Find out the unknown value. See how they have framed the question. Out of the, suppose if you consider 1 2 3 4 5 things, 1 2 3 4 are given, only one is missing. We learned that in algebra, if all the things except one are given, you can find that missing person or the missing algebraic term. Just like that, do it, and that's the answer. Let's see the next one. Okay. See the question. I will tell you how it's done, the and process. At a distance, it's a good question. Of 10 units from the point minus 8 comma 4. Okay, so first of all, see this, the point is on y-axis. Then what do you know? If a point is on y-axis, then it is not means touched with the x-axis. That means the abscissa will be 0. So then let the point, oh this is 10, okay, 10 units. Just wait. This is, oh, I know that will be horrifying if that was not given to you. Let the point be, see it's on y axis, so x axis or abscissa will be 0, b, and then the suppose y coordinate is 1. Okay, then now what they are telling, this point, the distance between this 0 comma y and this minus 8 comma 4 is 10 units. Coordinates, the find coordinates of a point on y-axis which is at a distance of 10 units from this. That means this y-axis coordinate is at a distance of 10 units from this one. Then, so what are the points? 0 comma y and minus 8 comma 4. This distance is 10. So then what is the distance formula for this two? x1 y1 x2 y2. Now do like the previous sum. Or now the distance formula is x2 minus x1 whole square, or minus 8 minus 0 whole square. plus y2 means this is not 4. Okay, y. Oh no, this is 4. This is 4, that one is y. y2 means 4 minus y1 is y whole square. And this distance, as I have shown you here with the reward diagram, is 10. Units given, but I am not writing units for my convenience. Then minus 8 minus 0 minus 8 square plus do this 16 plus y square minus 8y equal to 10, or root of y square minus 8y plus 16 and 8 square is equal to 64. Minus 8 square 64 plus 16 plus 80 equal to 10. Just like the previous one, square both sides, or on squaring I get this. Shift Mr. 10 to this side plus 70 equal to 0. So again I have a quadratic equation. You just see one thing. Y square and 16 equals to point minus x2 minus x1 whole square plus y2 is 4, I think. It's given 4. Yes. So 4 minus y square. Okay. So this is 10. Minus 8 minus 0 is minus 8. 64. And here y square, 4 square 16 plus y square minus 2 into 4 into y minus 8y. Okay. Then y square minus 8y. 8 square is 64. 64 plus 16 is 80. Okay. That is equal to, okay, here see. As I have squared it, so here also it will be 10 square. So it will be 100. Okay. See, I am squaring here, so this squaring removes a root, so obviously square this side as well. Then you get this one. Then shift 100 to this side. You will get 80 minus 100. This is equal to minus 20. Then equal to 0. Quadratic equation is on your screen. Then what? Do it. Or y square minus 10y plus 2y minus 20 equal to 0. I am doing it here. Or y into y minus 10 plus 2 into y minus 10 equal to 0. Or y plus 2 into y minus 10 equal to 0. Okay. Therefore, y plus 2 equal to 0 and y minus 10 equal to 0. Okay. Then, or y equal to minus 2 comma 10, right? So these are the possible values for y. Okay. So how did we get that? First of all, the point was on y-axis, so x-axis or abscissa was absent. So it was 0 comma y. The distance between 0 comma y and minus 8 comma 4 is given as 10 units, or x2 minus x1 whole square plus y2 minus y1 whole square equal to 10 root of, obviously. Then calculate this. After calculating, you get, and squaring, you get y square minus 8y plus 80 equal to 100. A quadratic equation is on your screen. Then you solve that. You get two values for y, which are minus 2 and 10. Therefore, the point on y-axis equal to what? 0 comma y, first one 0 comma minus 2 slash 0 comma 10. 2 points can be, because two values of y are there, right? So these are the points. This can be the points on y-axis at a distance of 10 units from this point. Okay. So that's the answer. I hope it's clear to you. Just remember one thing, when the point is on any axis, the axis is not mentioned. For x-axis, the abscissa will be 0. For y-axis, the ordinate will be 0. Which axis is not mentioned? Suppose x-axis is not mentioned, and abscissa is 0, the first part. If y-axis is not mentioned, then the ordinate will be 0, the second part. Okay. That's the process. And then just putting the distance formula like the previous sum, you can keep solving. You get two values for y. Then 0 comma y is the point we have taken. Then 0 comma minus 2 first value. Then 0 comma 10 the second value. Easy stuff. That's your distance formula. Can make a seemingly hard sum look like 1 plus 1 equal to 2. Okay. Let's see the next one. So what do we have here? What point on x-axis is equidistant from 7, 6 and minus 3, 4, I think it's given. Yeah. Okay, so the point, unknown point is on x-axis. Y-axis absent, that means ordinate will be 0. Therefore, let the point be x, 0. Right? Then according to the question, suppose here one point is there 7, 6 and here minus 3, 4 is there. This point, suppose this is the point, this is another point. This is x, 0. Okay. This x, 0 is equidistant from this point in what? This distance and this distance is same. They're trying to tell that. Or according to question, what? Equidistant. This point is equidistant from 7, 6 and minus 3, 4. Means this distance and this distance will be same. I repeated it again because I hope you can understand now. That means if we calculate this distance and this distance, that will be same. Then do or. Not or. Already I have written or. So root of first one. Here. The distance of these 2 points will be what? Here suppose x1, y1, x2, y2. y2 means 0 minus y1 6 whole square plus, so here what we have, x2 as x minus x1 is 7 whole square equal to, two distances are same. Now this distance, suppose this is x2 y2, this is x1 y1. Okay, then x2 minus x1, or so did we do, okay, y2 minus y1 first of all. So 0 minus 4 whole square plus x2 minus x1 whole square. That means x minus 3, it will be plus 3 if you can see. Why? x2 minus x1, that means x minus 3 is x plus 3 whole square. So that is the required relation, right? See, this distance and this distance is same. In other words, from this point up to this point and from this point up to this point, it is same. Therefore, if we calculate these two distances, it will be same. Now put the distance formula. Suppose this is x2, y2. For each of the cases, take x1, y1, x1, y1, put in the equation. Now do or minus 6 square plus x square minus 14x plus 49 equal to minus 4 square plus x square plus 6x plus 9. Easy. Or x square minus 14x minus 6 square is 36. 36 plus 49, 85 equal to root of x square plus 6x minus 4 square 16. 16 plus 9, 25. Got it? Then square both the sides to remove the root, or x square minus 14x plus 85 equal to x square plus 6x plus 25. I am squaring both sides to remove the root. Then see, on both sides x square is there, cancel it out. Now I have shift 6x to this side, minus 14x minus 6x equal to 25. Shift 85 to that side, minus 85, or minus 20x equal to minus 60, or x equal to minus 60 by minus 20, minus minus cancel, 3, or x equal to 3. So as x was 3, I will consider the point as x comma 0. Therefore point equal to 3 comma 0. That's the answer of this quite easy question, which I think. So you understood the concept. Again, the point is on x-axis, not on y-axis. Y-axis absent, that means ordinate is 0. You consider the point like that. So equidistant, this point is equidistant from these two. That means from this point to this point this distance, and from this point to this point this distance is same. Then we calculated the two distances using the distance formula, and now we get the equation. We remove the root, squaring on both sides, we do that, and then remove x square on both sides, then shift 6x to this side, 85 to that side, and minus 20x equal to minus 60, and x equal to minus 60 by minus 20 equal to 3. And as we considered the point as x comma 0, x is 3, so 3 comma 0 is the point. That's how you do it. Okay, from in every question you will be means have to take the unknown point in this form, abscissa ordinate form. Then according to the question you can frame the relations like this. It's quite easy. The distance formula is helping us quite immensely here. Let's see the next one. One formula. So we will see till the end how many types of uses this has actually. We'll also learn about circumcenter, which is also a special case of distance formula in a triangle. Okay, so you'll see that how it's done. Okay, now 7. Question 7. P lies on x-axis. Wait guys, 1 minute. Okay, so P lies on x-axis and Q lies on y-axis. If abscissa of P is minus 12, they are giving an easy question. And ordinate of Q equal to minus 16. Find length of PQ. It's the distance of P from Q. It's a Google type of a question. First of all, first step. So P, it is lying on x-axis. So y-axis is missing, right? That means ordinate of P it is missing. So P lies on x-axis. I think it's written. Wait a second, guys. Okay, no, it's like it's twisted actually. Abscissa of Q is minus 12, ordinate of P is minus 16. Find length of PQ. Okay, I understand it. So abscissa of Q is minus 12, ordinate of P is minus 16. I just wrote it means opposite way. No worries. So see this point P, it lies on x-axis. So y-axis is missing here, right? So that means ordinate is missing. So we can consider the point P as x comma 0 and Q is what? It is lying on y-axis. That means x-axis is not involved. That means abscissa is not there. So you can consider it as 0 comma y. But abscissa, sorry, ordinate of P equal to minus 16 given. Now see. Okay, what is this? P lies on x-axis. Okay, actually I wrote it correctly in the first part. I don't know, I rubbed it. Sorry guys, okay. So this is abscissa. I just got confused a little bit. So see this. So what is this? See, they are telling that abscissa of P is minus 12 given. Now ordinate of P is already 0, but abscissa of P is x, but abscissa of P is minus 12 already given. Therefore P equal to minus 12 comma 0. First of all, see, as the point was lying in x-axis, we took y-axis as 0 or ordinate as 0. But P's abscissa was already given, so again we substituted it. Now for Q, also ordinate of Q equal to minus 16 given. See, we are doing using given things. Now see, the point Q was on y-axis, so we consider the x-axis of the abscissa as 0, and y-axis ordinate is y, any unknown value, but the point y or the ordinate of Q, which is y we have considered, is already minus 16. Therefore Q equal to 0 comma minus 16. Originally it was on a y-axis, so ordinate was y, x-axis was 0, but already the ordinate is now given to us, to all of us. Substitute it. So now you have P as minus 12 comma 0 and Q as 0 comma minus 16. Therefore PQ distance. Now what? The most easy part. It's becoming easy because now we are getting accustomed to the formula. Take this one, x1 y1 x2 y2. So x2 minus x1 whole square, 0 minus minus 12 whole square. This 0 plus 12 whole square. Plus y2 minus y1 whole square, that means minus 16 minus 0 whole square, equal to 12 square plus 16 square, equal to root 144 plus 256 root 400 equal to 20. That's your answer. So see the tricks. Originally P is on x-axis, y-axis ordinate 0. Q is on y-axis, x-axis abscissa 0. But P's abscissa is given to us, so we substitute it as minus 12. Q's ordinate is given to us, we substitute it as minus 16, which we are taking as y, an unknown value. And this one, the abscissa, we are taking as x as an unknown value. Now when we have P and Q, x1, y1, x2, y2, use the formula, substitute the values and get the answer of 20 units. Quite an easy sum. Let's move to the next one. It's easy. If you just do the correct usage of the formula, this can be quite a easy stuff. So now we have a proving. Prove that P 0 comma minus 4 comma Q 6 comma 2 comma Q 3, no, not Q, R 3 comma 5 and S minus 3 comma minus 1 are vertices of rectangle PQRS. So then, suppose it's a rectangle labeled as PQRS. Then what do we know? The opposite sides of a rectangle are equal. Therefore, PQ equal to RS and PS equal to QR. Now, PQ is what? Calculate the length of PQ. x2 minus x1 whole square. So here I am not doing it directly. x1 y1 x2 y2. x2 minus x1, that means 6 minus 0 whole square plus y2 minus y1 whole square. Means 2 minus minus 4 means 2 plus 4 whole square equal to root of 6 minus 0 6 square 36 plus 2 plus 4 6 square 36 equal to root 72 units. Let it be as it is. Then you are coming to You also need to calculate QR. QR is what? The distance between Q and R. So 3 minus 6 whole square plus 5 minus 2 whole square equal to minus 3 square plus 3 square. Wow, what is this now? Is 0? How can that be? Is it 3 comma 5 or something else? Yes, it is like that. X1 y1 x2 y2 x2 minus x1 whole square, 3 minus 6 whole square, and here 5 minus 2. Okay, it's all right. Minus 3 square 9, 3 square is 9, equal to root 18 units. Gone. Then RS equal to what? Okay, RS is the distance between R and S. X1 y1 x2 y2, then do equal to root of x1 x2 minus x1 whole square minus 3 whole square plus y2 minus y1. Y2 is minus 1 minus 5 whole square equal to root of minus 6 whole square plus minus 6 whole square equal to 36 plus 36 equal to root 72 units. Gone. RS is done. Then comes Mr. RS, then PS actually equal to, again for this one do, so PS, so distance between P and S, x1 y1 x2 y2 x2 minus x1 minus 3 minus 0 whole square plus y2 minus y1 minus 1 minus minus 4 minus 1 plus 4 whole square equal to minus 3 minus 0 square minus 3 square equal to 9 plus minus 1 plus 4 means 3 square 9 equal to root 18 units. Now see, we have got the lengths of PQ, QR, RS, PS. What was the condition? PQ equal to RS and PS equal to QR. Therefore, PQ is what? Root 72 units equal to RS, where are you RS? Where are you my friend? RS we got root 72 units. And this is now legit. PS equal to QR. PS we got root 18 units. Equal to QR. QR, where are you my friend? Where we found you? We got QR as root 18 units as well. Now see, for a rectangle, the opposite sides need to be equal. PQ and RS should be equal. QR and PS should be equal. We have proved that, and as that is proved, therefore proved. That was the proof, right? To prove that they are the vertices of a rectangle. So in each of the cases, for finding the lengths of the line segments, you are having 2 points. For PQ, these two, QR, these two, RS, these two, PS also the 2 points. For each of the points, 2 points given. Consider x1, y1, x2, y2. You can substitute the values, and you will be getting these answers only. The lengths of PQ, QR, RS, PS by using the distance formula. And you see PQ equal to RS, PS equal to QR. That's the requirement. Opposite sides should be equal for a rectangle, and that means these are the vertices of the rectangle PQRS. Easy proof, right? Just need to find the lengths and check if the opposite sides are matching or not. If yes, your game. If no, wrong in the question. They will never give an incorrect proof. They will give the sum in such a way that you get the correct answer, unless you make a mistake in the process yourself. So let's see the next one. I was talking about circumcenter, right? So it is here to entertain you all. So let's see question 9 now. Is it 9? I think. Yeah. Question 9. So vertices of a triangle are 5, 1, 11, 1 and 11, 9. Find the circumcenter. It's a direct question. So first of all, let me explain what is circumcenter. First of all, the triangle. This is a triangle. Suppose I give the names P5, 1 just for the convenience. Okay. Q11, 1, R as 11, 9. All right. So this means what? Suppose PQR, right? So P5, 1, Q11, 1, R11, 9. So circumcenter is a point from which the points P, Q and R are equidistant. That means this distance, and this distance, they will be same. So this dot is called the circumcenter. Okay. A point in a triangle from which all the vertices are equidistant is called a circumcenter. So suppose this circumcenter, I let the circumcenter be ax comma y. Let the point be a and its coordinates x comma y. That's right. So I have got is equation that all the distances means PA equal to PQ, PA equal to PR, AQ equal to AR, AQ equal to PL, like that it keeps going on. But how I need to solve this? Or PA equal to AR, I can write that, or C. So here, therefore, PA is what? So PA's distance formula, what will it be? Suppose x1 y1, x2 y2. So x2, x minus 5 whole square and y minus 1 whole square, y2 minus y1, equal to root of AR. So AR I have considered. So suppose AR's distance formula will be x1 y1 x2 y2. Suppose x1 y1 x2 y2, x1 y1 and x2 y2. So x minus 11 square plus y minus 9 square. So I told PA equal to AR, right? Then do it. Or root of x square minus 10x plus 25 plus y square minus 2y plus 1 equal to root of x square minus 22x plus 121 plus y square minus 18y plus 81. Okay. Then just square whole the both sides. The roots will get removed, so I can just simply write x square plus y square minus 10x minus 2y plus 25 plus 126 equal to x square plus y square minus 22x minus 18y plus 121 plus 81 plus 121 plus 81 plus 202. It's complex, but let's see if we can solve. So x square y square get cancelled out. Then bring all of them here, minus 10x If you bring minus 22x this side, plus 22x, plus 22 minus 12 plus 12x, minus 2y plus 18y, bring it to this side, plus 18y plus 16y equal to 202, bring it, okay, no, shift 26 to that side, then you become 202 minus 26, so that is equal to your, just calculate, 186 or 176, yeah. Divide the whole equation by 4, you get 3x plus 4y equal to, it is your 8844. Keep this as 1. Oh, it took a lot of space. So I got that PA equal to AR. I just got it. Then PA also equal to AQ, I can tell. So let us do, then I got PA. I got the equation of PA as this one already. Also PA equal to AQ. Okay. So therefore PA's equation is this one already, you have got it. So x minus 5 whole square plus y minus 1 whole square equal to root of AQ. AQ's equation again x minus 11 square plus y minus 1 square. And I am just directly calculating, okay, you can directly do it, I know. I'm just doing the calculation directly. See how easy it is. 121 plus 1, 122. Then the square both sides, or I'm doing it here, okay. So squaring both sides, x square plus y square plus 10x minus 2y plus 26 equal to x square plus y square. Don't take up my whole space. 22x minus 2y plus 122. Then get this 2 out of the way. And if you do the common calculation, 10x, wait a second, 10x, okay, yes. Oh no, it is minus 10x or plus 10x? Yes, it is minus 10x. I did a horrible thing. Minus 10x plus 22x, so that is 12x minus 2y. Okay, so here we have something as well. So minus 2i is on both sides. Just get it out of the way. Plus 26. So this is 122 minus 26 equal to, it is 96, I think. Yep. Or x equal to 8. Wow, what a remarkable thing. I just got from this equation PA equal to AQ the value of x as 8. But I also got a equation 1, 3x plus 4y equal to 44. Or I substitute the value of x, 3 into 8 plus 4y equal to 44. Or 24 plus 4y equal to 44. Or 4y equal to 20. Or y equal to 5. Okay, I'm putting 2 ticks here. So, have you got x and y? Through a horrible, huge process, I will summarize it properly first of all. So see, circumcenter is a point from which all the vertices of a triangle are equidistant. That means PA equal to AQ, PA equal to AR. I take the two equations. So PA's equation, this one, equal to AR's equation, this one. Then doing the calculation, then squaring them up, I get, after solving, minus 10x plus 12x minus 2y minus plus 18y plus 16y equal to 202 minus 26 176. So divide this equation by 4 divided by 4. Then I get this one. That's the first equation. I also have PA equal to AQ. So PA's equation is this one equal to AQ's equation is this one. After solving, you get this. Then just keep doing it here as well. I'm just checking one thing, guys. Yes, it is minus 2, obviously. Then after calculation, just always in both the steps do the square to remove the root. Then you see x square y square get cancelled. Minus 2I also get cancelled now. Then 12x equal to 96. I get it. Then x equal to 8. So I got the value of x. Now using this value of x, I will substitute the value in equation number 1. So I get 3 into 8 plus 4y equal to 44. Then just means after substituting and calculating, you get y equal to 5. So I am writing here this way. Therefore, circumcenter A, it is xy, x is 8, y is 5. This is the means most largest sum I think for any chapter I have done. Wow, very nice. So it's a single sum. I have done means 2 sums, 3 sums combined in one question. That's why it took a lot of space. But here one sum only because of means see. You have to calculate the distances of PA, AR, AQ. And then if you see that PA equal to AR, you get an equation. You see PA equal to AQ, you get an equation. Using this value, you substitute it here, then get the value of y. So it takes a lot of space, right? But that's the answer actually. Quite easy. Just you have to means be careful. The basic is from the circumcenter, all the vertices are equidistant. Means PA equal to AR, PA equal to AQ, and PA also equal to PA equal to AQ and PA equal to AR. And also AQ equal to AR, AQ, yes, like that. So that's the relations, okay. And then if you get two relations, you will be by either simultaneous linear equation or by substitution you will get the values of x and y, okay. So that's the process. Let's see the next one. Took a lot of space. Probably the last sum for today as well. Last sum of distance formula. Very well designed chapter for class 9. Let's see the last question. It must have a twist. Yeah, it's a good question. Distances of P, x, y from the points A1, minus 3 and B minus 2, minus 2, 2 are in the ratio 2:3. Prove. What to prove now? A big equation I can already see. 5x square plus 5y square, but it's easy. You will soon find out that. Minus 34x plus 70y plus 58 equal to 0. Now you'll be telling, what does this equation have to do with those 2 points? Something with the distance formula which I accidentally rubbed. I hope you remember root of x2 minus x1 whole square plus y2 minus y1 whole square for any 2 points x1, y1, x2, y2. Talking about that, so this distance, suppose pxy is 1 point from here up till q, or not q, always I consider q, like q is the brother of p, it's like that. And this again from P till this point, suppose B minus 2, 2. They are telling that this PA, according to question, this PA distance divided by this PB distance, or let me just write it, PA is to PB, the distances of PA is to PB equal to 2:3, or PA by PB equal to 2/3. Okay. Or now comes the main question. So what is the distance of P then? PA, x1, y1, x2, y2, do it. Root of x2 minus x1, 1 minus x whole square plus y2 minus y1 minus 3 minus y whole square divided by root of PB is distance x1, y1, x2, y2, x2 minus x1 minus 2 minus x whole square plus y2 minus y1, 2 minus y whole square. Forgot to put the bracket, horrible stuff. This ratio is equal to 2 by 3. Already you can see the answer, I know. Then just do the calculation. I am doing it directly here. So x square plus y square, and here comes your 1 minus x, 2 into 1 into minus x minus 2x, and here comes 2 into a into b minus 3 into minus plus 3y plus 6y, and here plus 1 and plus 9. So 10 divided by again x square plus y square. Then here comes your 2 into 2 4x, 2 into a into b as 4x, and here comes minus 4y plus 2 minus 2 square 4, 4 plus 4 8 equal to 2 by 3. So I just did the calculations, okay, but directly here you can do that by any method, a square a plus b whole square, a minus b square, any way you like, and then the c. So now what you have to do? Square both sides, then this roots will get removed. Like suppose root PA by PB equal to 2 by 3. Root PA square equal to what? PA and root PB square equal to PB equal to 2 square 4 by 3 square 9. Similarly here, okay, I am writing root y. So PA square will be this one, root value square. So x plus y square plus y square is 2x plus 6y plus 10 divided by x square plus y square plus 4x minus 4y plus 8 equal to 2 square 4 by 3 square 9. Got it? Just square both the sides, okay? Then here I am shifting it just. Now just do cross multiplication or. So 9 into x square plus y square. Now the game is almost over here. 10 equal to 4 into x square. Just cross multiplying, guys, nothing else. Minus 4y plus 8. Let's get this done with. Or 9x square plus 9y square minus 18x plus 54y plus 90 equal to 4x square plus 4y square plus 16x minus 16y plus 32. Okay, which space do I have to solve a sum here? I think shift 4x square to this side, it becomes 9x square minus 4x square, 5x square plus 9y square might shift 4y square to this side, it becomes 9y square minus 4y square is plus 5y square minus 18x plus 16x. Shift plus 16x to this side, it becomes minus 16x minus 18x minus 16x equal to minus 34x plus 54y. Here minus 16y, shift minus 16y to this side, it becomes plus 16y, 54y plus 16y equal to plus 70y. And finally 90 and a 32, shift 32 to this side, plus 90 minus 32 equal to 58, and nothing on this side. Therefore proof gone. So it was an easy proof, right? The distances of P from A and B was in the ratio 2:3, or the distances of PA is to PB equal to 2:3, or PA by PB equal to 2 by 3. And PA's equation is this, PB's equation is this, equal to 2 by 3. Then PA square by PB square equal to 2 square by 3 square. PA square, the root gets removed, PB square, the root gets removed. 2 square 4, 3 square 9. Do cross multiplication on both sides. Then all of the terms on this side, get them to the left hand side. You will automatically simplify for x square, x, y and the constant value and get this equation. That is all about distance formula. So it's a formula basically where you have to know one thing. you can frame multiple relations from which you can find out the value of some unknown quantity or unknown coordinate. Okay. And also remember, for a point A, suppose x comma y, that x is of the first point is called the abscissa present on x-axis, and the ordinate, which is y, is present on the y-axis. Okay. Whenever means a point is on y-axis, then the x-axis is absent, so abscissa absent, 0 will be there in place of abscissa. If point is placed on x-axis, then y-axis is absent. On y-axis 0 will be there, on ordinate 0 will be there, abscissa x will be there. Okay. And circumcenter is a point from which all the vertices of a circle are equidistant. That means you can just from that figure out that for any two distances, PA equal to some, I just did one sum. Okay, like that you can frame the relations and you can get the circumcenter for yourself. And this is quite easy as well. Ratio means the two distances are in the ratio. This means that one distance by another distance equal to A by B. Then do cross multiplication using distance formula first of all, and you can get the answers of these sums quite easily. So a lot of sums are there actually from this chapter. I just solved a few to make the concepts clear for you on this chapter. And yes, this chapter is completed for class 9 within one video actually. So I hope you understood the formula. All summary: distance between 2 points A x1 y1 and B x2 y2 equal to root of x2 minus x1 whole square plus y2 minus 1 y1 whole square. Yeah, that's the formula. Remember it and you will succeed, because sums come in some proportion in the exam from this chapter. So I hope that you will score good marks because it's a very easy formula. So with that I finish this chapter for class 9. So then, if you found my video on distance formula for class 9, and if that simple formula, circumcenter, and all the conceptual sums that I did for you were clear and helpful for you, leave a like and share and subscribe my channel. It motivates me to make better videos for my little friends on these interesting topics. And as this chapter is completed within one video, we are going to start a very new chapter in the next video for class 9, and that chapter is going to be started in 2024, because I will be releasing the video after 2 days I think, and after 2 days we are welcoming the new year of 2024. So enjoy the New Year's Day. Stay safe, stay happy. Till then, take care and goodbye. Thank you.